Welcome to another video by Supernal Tutorials. In this video we'll be focusing on solve for X type questions. These questions were extracted from the Department of Basic Education November 2020 question paper. For our first question we'll be looking at solve for X, right, as it is written there on 1.1. Question 1.1.1, we have x squared minus 6x is equals to 0. What we do, we first need to make sure that on the right side of our equation we have 0, and that condition has been met from the given question. So on the second step we factorize this equation. By factoring out, we first identify what's common between the terms of the equation, and we can see that there's x, which is there in x squared, and it's also there on negative 6x. So when we factor it out, it's like we're dividing through by x, right? So we have x open bracket x minus 6 close bracket is equals to 0. So for the following step we separate these two things, right? Then we're going to have x is equals to 0 or x minus 6 is equals to 0, and then we take 6 to the other side, which then gives us x is equals to 6. With more practice you're going to get used to this method. Okay. And then for our following question, which is 1.1.2, we have x squared plus 10x plus 8 is equals to 0, and then we are told that our solution should be correct to 2 decimal places. For this type of questions I always recommend that we use the quadratic formula, because not everyone's skills for factorization is as high, right? And this will save you time. So the quadratic formula is written as follows: x is equals to negative b positive or negative square root b squared minus 4ac all over 2a, right? So first, for you to be able to apply the quadratic formula, you need to be able to know what all those letters represent from your initial equation, right? So the standard quadratic formula is as shown there: ax squared plus bx plus c is equals to 0, right? So in the given question, if we relate the standard quadratic form to the given question, we'll see that from our given equation and the standard quadratic form, that our a will have to be 1, right? And our b will have to be 10, and our c will have to be 8, right? These are the other numbers that you would have to substitute into the quadratic form for you to get the same equation as the one we have on our given question. So that is what I'm trying to say. The previous page we've shown that our a is 1, our b is 10, our c is 8. So when we substitute these numbers into the quadratic formula, it will be substituted as shown on the first step on this page, right? And then we punch this into the calculator. So you need to be careful here. Where there is that positive and negative sign, that simply means that when you punch this into the calculator, you have to do 2 separate calculations. For the first calculation, you'll put it as positive, right, as plus, right, and then you get your answer, and then you go back there, remove the plus and put a negative, and then you get a different answer. So in this case, when we added a positive, we got x to be negative 0.88, and when we put the negative there in the equation, we got our x to be negative 9.12, right? So remember, we were told that we need to put it correct to 2 decimal places. This was also an indication to show that we should expect an answer which will have decimal places, right? And as we've shown here, both answers have decimal places. Okay, and then for our second question, 1.1.3, well, excuse me, the third question, right? We have in brackets 1 minus x, and the second bracket we have x plus 2, which is all less than 0. So as we do, right, don't be confused by the by the inequality sign, which is less than 0, right? Don't be confused by it. We also apply the same method as the as in the as in the first question, whereby we separated those are brackets, right? So we have 1 minus x is less than 0, and then we separated the second one, which then gives us x plus 2 is less than 0. So what we do is that we treat them individually, right? So let's start with the left side, right, whereby we have 1 minus x is less than 0. What we do is that what we did was that we said we took the 1 to the right side, and then we were left with negative x. It's less than negative 1, right? So to simplify this, we divide through by negative 1 on both sides, and when we do that, as shown in the step here, you can see that when you divide by negative 1, it's now x is greater than 1. So what you need to know is that when we are dealing with inequalities, when you divide by a negative number, the inequality sign switches, right? So initially we had x is less than negative x is less than negative 1. Now we are going to have x is greater than 1, and then considering the second bracket to the right, which is x plus 2 is less than 0, we simply take the 2 to the other side, and then we have x is less than negative 2, right? So on this diagram here that I've drawn here for question 1.1.3, what you need to know is that the first part, which is the part below, right, that is the number line. On the number line, you simply represent your critical values, right? Of course, since it's a number line, the numbers are what are in increasing order, right? From the smallest number on the left to the highest number to the right. Okay, so as you can see, to my left I have negative 2 and 1. You simply represent them like that, and then the arrows above, right, these ones, let's check the negative 2 side first, right? So we have x is less than negative 2, which means that our value for x, it's any number less than 2. So hence, right there above the number line where we have negative 2, we've shown an arrow which is pointing to the left side of negative 2, which means x is a number which is less than. So as you know, a number line, right, we have negative 2 there. So which means that if we were to go to the left side of the number line, we would have a number which is less than negative 2, say negative 3, negative 4, and so forth. So that is why it's pointing to the left side of the number line. And then when we consider our answer for x, which is greater than 1, we draw an arrow right there above the number line where we have 1, pointing to the right side, which shows that x can be any number which is greater than 1. And notice something about these arrows above the number line. They are represented with an open circle right there. The way I drew those arrows, it's an open circle to show that the number is not necessarily that specific number on the number line, which is in our case the x is not necessarily negative 2 or 1. It is greater. So that is why the circle is open, to show that those two numbers being negative 2 and 1 are not included into the solution. It's an open circle, so which means that those two numbers are not necessarily part of the solution, hence it is an open circle. So please don't stress much about this. It's something that you are going to get used to with more practice. So if you don't understand this part of the solution, please seek further help from your educators, or you can try to make contact with us and we can try to explain more to you. And then on the following question, which is 1.1.4, we have square root of x plus 18 is equals to x minus 2. For our first step in this type of question, for us to be able to do anything, we need to get rid of the square root on the left side. And how do we get rid of a square root? We have to put everything in that square root to the power of 2, as shown in the first step of as shown in the second step of 1.1.4. We've squared the left side and the right side. Remember, it is always the rule that you need, whatever you do on the left you need to do on the right. So hence we have squared both sides. And when you square a square root, it gets rid of that square root, and then we have x plus 18. And then when we expand, we have what? X plus 18 equals to what? The expansion of x minus 2 squared. The expansion will then be x squared minus 2x minus 2x plus 4. And then when we simplify this, on the fifth step, we have x plus 18 is equals to x squared minus 4x plus 4. And then we bring leg terms together. So we simply took that 18 to the right side, and we took the x to the right side as well. And then we remained with 0 on the left side. So when we simplify the right side, we have what? X squared minus 4x minus x plus 4 minus 18. When we simplify this on the last step of the equation, we have 0 is equals to x squared minus 5x minus 14. And then use the quadratic formula as I've demonstrated in 1.1.2. As a guide, I've mentioned that in this case our a will be 1 and our b will be negative 5, our c will be negative 14. Please always try to pause this video and actually try out the questions on your own. For our question 1.1.4, we have found our x to be 7, or x is equals to negative 2. And then going on to the next question of 1.2, we are asked to solve simultaneously for x and y. Right? Please try to pause this question and try it out for yourself. Okay. For the solution in this question, we have what? X plus y is equals to 3, and 2x squared plus 4xy minus y is equals to 15, right? What you need to do, it's always advised to actually take the simplest equation first, and take any variable, whether x or y, and make it a subject of the formula. So I chose to make x in equation 1 subject of the formula. So making it subject of the formula, this is what I've done. So I wrote x plus y is equals to 3, and for the second step I took y to the right side, leaving the equation as x is equals to 3 minus y. So I've made x the subject of the formula. And then this x is equals to 3 minus y defines a new equation for me, which I've named it 3, right? So for the next step, I substitute equation 3 into equation 2. Please don't substitute equation 3 into equation 1. It's going to give you 0. You'd have done nothing, because remember, equation 3, it's derived from equation 1. So it's always if you had started with equation 2 and made whatever variable in that equation to be subject of the formula, you would then have to take that new subject and substitute it into equation 1. Okay, I hope I'm making sense. So okay, for the next step, I said substitute equation 3 into equation 2, right? For the first step, I wrote equation 2 as it is, which is 2x squared plus 4xy minus y is equals to 15. And then for the second step, I substituted for x, which is 3 minus y, and then to the squared, right? Plus 4 3 minus y multiplied by y minus y, right? And then it's equals to 15. So you simply work out this expansion, right? And then as you go down, please be careful here, because it's a bit tedious, right? So I simplified it until the last step. I had 2y squared plus y minus 3 is equals to 0, right? So I took this 2y squared plus y minus 3 is equals to 0 and used the quadratic equation as previously shown. For the quadratic equation, in this case, our a will be 2, our b will be 1, our c will be minus 3, right? And then using the quadratic formula, I found that y is equals to 2 or y is equals to minus 3, right? And then for the last step, I said therefore okay, I brought back equation 3, right? Because it is the simplest way that I can find x, because now I have my y values. So I will use these y values to get x values. As you can see, there are two y values, which will then give us two different x values. So for the first one, I said x is equals to 3 minus 2. First y value is 2, so this gives us x is equals to 1. And the second part, I said x is equals to 3 minus 3. Please be careful here when you substitute in the y value. Remember, in our initial equation we have 3 minus y, so this is going to give us a positive, which then gives us our answer as x is equals to 6. For our last question of this video, which is 1.3, we are told that if n is the largest integer for which n to the power of 200 is less than 5 to the power of 300, determine the value of n, right? So remember, this is a solve for x type question. So before you stress yourself on a lot of words mentioned here in this question, first try to solve the equation. Remember, n to the power of 200 less than 5 to the power of 300. It's an inequality type question, right? So we are going to look at it as any other general inequality question. So for the first step, we wrote n to the power of 200 is less than 5 to the power of 300. So to solve this and to isolate n in order to figure out what n could possibly be, we apply laws of logarithms. Please, if you are not familiar with laws of logarithms, you can search for them on the internet and practice on how to apply them, right? So if we apply a log, we have to apply it on both sides. So log n to the power of 200 less than log 5 to the power of 300. when you apply it, it takes down the 200. So we have 200 log n less than 300 log 5, right? Sorry for the cancellation here. I was about to go forward with the step, and this was going to actually disturb the explanation, or rather it was not going to allow it to be clear on how the steps were taken here. So I rewrote it again. So 200 log n less than 300 log 5, right? So the first thing that we can do here, we can simply simplify these constants, right? Which is 300 and 200. So what I did was I divided I divided 300 by 200, leaving the left side with log n is less than 200. It's less than 300 over 200 log 5, right? So it simplifies to be log n is less than 3 over 2 log 5, right? So now on this step, right, since we have log n and 3 over 2 log 5, now this is a bit similar to what we had on our second step, whereby we applied laws of logarithms, right? So the same law can be applied in reverse, which then removes the log and takes it back to normal numbers, or rather the normal the initial standard which it was in, right? So imagine that in front of this log n, right, there is a 1. So when you remove it, it takes the power back up, right? So we'll have n to the power of 1, and right, and then on the right side, since we had 3 over 2 log 5, right, since we're removing the log, this 3 over 2, which is in front of the log, goes back to be the power of the number in front of the log, right? In this case, which is 5. So this 3 over 2 then comes back to be the power of 5, as I've shown here. So when you simplify this 3 to the power, when you simplify this 5 to the power of 3 over 2, you get 11.18, right? So now here is where that if n is the largest integer part comes in, right? So remember, okay, so notice that, okay, n to the power of 200 less than 5 to the power of 300, right? So this is the n value which will allow that condition to be met. So this 11.18, right, allows the condition to be met. So this is like the critical value. So this is like the specific number that accommodates that condition of n to the power of 200 less than 5 to the power of 300, right? This 11.18 is the exact value, or rather the critical value, which allows this condition to be met. So since now we are told that we need to determine the value of n, for which n will be the largest integer to accommodate this condition, first we need to understand what an integer is. An integer is a whole, it's a what? It's like a whole number, right? Without it's a no. Let me rephrase that so that you are not confused. An integer is it's a number without decimal places. It's not a fraction. It's a complete number. You get me? So so then in this case, our largest number will then be 11, and the reason for this is that someone might be wondering what would have been done if the number was 11.5. Wouldn't we then round it up to be 12? No, that's not the case, because the moment we take the number beyond 11.18, then that condition of n 200 less than will not be met, because that would make n 200 to be what? To be actually greater than 5 to the power of 300. Then that is why we round down, because the number to the left needs to be less. So the largest integer, the largest complete number which will allow this to be met, it has to be a number less than 11.18, which is then 11. It can't be a number above that 11.18. I hope that makes sense. Thanks for watching this video. If you have any questions, please try to make contact with us, and then we can offer more assistance. We apologize for making this video very long. It's just that we want to ensure that all the concepts are fully understood, because the same concepts are repeated but in different forms. So if you pay attention to everything that I'm saying, you will actually have a more in-depth understanding of these concepts. Thank you.